Hello guys, welcome back to our channel The Engineer. Today we are going to discuss about oil water separator. In that we will briefly discuss the construction, operation, working principle of oil water separator, and we will get the familiarized with different part of the system, and at the last I'll explain the SOLAS regulation for the oil water separator. So guys, let's start. So this is what the oil water separator looks like on board. um, Actually I have sold whatever the model which I have been seen from my past sailing is the same which I have been shown on the screen. So basically this is a shell of the just be see that red dot. In that you can see that this is the shell of oil water separator. This is the inlet pipe from the bilge holding tank, okay, and this is the non-return valve. So this is a power unit, and this is a oil measuring device, oil monitoring device, okay, OMD. And here you can see this is a freshwater inlet for the oil water separator. This is a pump which is a single screw pump, positive displacement pump, okay. This is adsorber. So okay, and is equipped with the pressure gauge. This is a motor for the pump, and you can see this is a manual three-way valve and auto three-way valve. You can see here, okay. This is the heater, and here you can see that this is a 3-probe sensor, and this two line, this one and another one, this one line goes to the oily separate oil tank, and the another line goes to the bilge holding tank, okay. In this control panel you can see this is a power switch, this is a manual on off, and there is a manual hand auto, like a few different operations are there, okay. And here you can see this panel, whatever the sample water which get collect over here, it get drained to the bilge holding tank. So for that this is basically provided. So this is all about the external familiarization, external diagram from the manual which I have been taken, okay. In that, here briefly explain about the number 2 button. Here is then power supply, which already I have been explained you all guys. In that you can see the control box, oil discharge, back washing outlet, okay. Here is a back washing outlet, and a sensor, electrode, electronic heating, monopump, back washing light, oil monitor, bilge water inlet to the bilge water tank, and sample water inlet, flushing water inlet, sample tap, adsorber to overboard, and bilge water tank. So this all you can just have an overlook on this thing which I have been already explained you guys, okay. So okay, this is what you guys can see the section which I have been drawn, and here you can see what are the internal parts of the oil water separator, okay. Whatever the drawing made is as per by manual only, but in a simple form. And also I have been worked on this type of system. So as per by my experience and everything, I have been drawn this. So here we are going to discuss more briefly, and then I will show the animation. In that you can get more bit idea about the oil water separator operation. So as last we have been discussed, this line comes from the bilge holding tank, and there is here this valve also a non-return valve, which prevent the water flow from this side to this side. It only allows the water flow from this side to this side. I forgot to just mention that valve is that non-return, but this is a non-return valve. Here you can see it is a filter, and then this is the non-return valve, which I have been shown in last photo, okay. Now this water which has been there is a regular pipe which will come along to up till it opens on the top of the coil cell. Now we will discuss what are the parts inside this shell. This is a shell, okay. Here this is a coil cell. Coil cell, from outside, from the transverse view we can see this, but it looks like this. These are the two rings which give the support to the this thing. It's like a fed filter, you know. It's like wrapped in a circular motion. This is a filter. It's like wrapped, and a lot of fields are there and which have been wrapped. So this is a coil cell. Best its a function is that it makes the small droplet and combine it to a bigger droplet so that it get floats on the top, and better separation we can get by this coil cell. So this is a very important part in the separation process. So this is a coil cell, and then you can see here is a heater. Like as we know that if we heat, the separation will be good, so for that heater is provided. Now this is a three probe sensor. It's very important because it has a three probe, and three probe has its different function. Like one probe is for the sensing the water, another probe says the oil, and another probe says the air, which has been very important. We will discuss later about it. This is a pressure and vacuum gauge which shows the pressure vacuum, and this line goes to the oily bilge tank, and this line goes to the bilge holding tank. Now later here is an that pump which I have been shown in the last diagram, where that single screw pump, and this is a safety valve which is located on the pump, and or pressure regulating valve, and this is a three-way valve which makes to way to the adsorber, or it bypass the adsorber, which is Atto valve. And then you can see the manual three-way valve, and then Atto valve, and then it's going to, that is the funnel which drains out the bilge holding tank to a drain which goes to the bilge holding tank. And this is a drain. If we want to drain for some maintenance, then we have to drain it through this drain. Okay, this is adsorber. Inside the adsorber, this is like cartridge filter. These are the cartridges which are mounted inside this, and whatever the water, it flows from this, and then goes like this. So whatever the oil particle get trapped inside this, so we regularly in maintenance we have to clean this filter or change this as per the manual. We have to work, but this is what inside the adsorber. Okay, now in an operation, now first what happens in the starting of the oily water separator, it's very important, listen carefully. Now initially this oily water separator is empty. Okay, so first we supply the fresh water to the oily water separator. So this valve get opens, and the fresh water comes to the system, and it get fills up, and it get filled to the full system. Okay, once it is filled, there is a sensor which senses the water. So once it has been sensed that the separator is full, then the freshwater valve get closed. Then the signal goes to the pump, and pumps get started. So as this valve is closed, pumps takes the suction from this side, and the water flows from this to the overboard. Now as pump is taking the suction from this shell, the vacuum get created inside the system. Once there is a vacuum, so this vacuum pulls the water from the bilge holding tank to the system. So whatever the water which get pulls up and get out from the here, and it passes through the coil cell and then get through the pump. So this is how it creates the suction. So after that, what happened, because of the gravity separation, the oil particles are lighter than the water, so it get floats on the top, and the water gets settled to the down, and it get passed through the this pump. Okay, so what happened, the outlet to this, from here one line goes to the oil monitoring device, which measures the oil content, and if it is less than the 14 ppm, what I am saying is less than the 14 ppm, then it bypass the adsorber and it goes directly to the overboard. And if the oil content is 15 ppm or more than the 15 ppm in that water, if oil content is 15 ppm or more than 14 to 15 ppm, then the water passes through the adsorber and then it goes to the overboard. And if the oil content goes more than the 15 ppm, this three-way valve open and the water goes to the bilge holding tank directly. So this is the function of oil monitoring device. Okay, now so all the process has been done. Now what is the next process? See, once it has been detected there is the oil in the water, so what happens, the process get stopped. So in that the pump, after accumulation of oil, there is a sensor which senses the oil content, and if there is an oil content, then pump gets stopped and fresh water get into it for the back flushing purposes. So the fresh water gets in and pushes up the oil. This valve get opens and the oil gets to the, it get back flushed, whatever the oil content, it get to the oily bilge tank. Once the probe senses water, it gets stopped and then the system stops. Okay, now after sensing water, this valve opens and water flows. Once the back flushing happens, all the valve closes and the procedure resumes. So this is how this oily water separator works. Actually there is one more phenomenon, that pump is given other side of the system. It has advantages that it won't create the like emulsion. It prevent creating emulsion and gives a laminar flow, so it's better for the separation system. So that is one advantage for that specific pump providing up here. Okay, so this is all guys, how the separation occurs and what of the procedure. But in the next part we will briefly see how exactly all the procedure happen, which I have been explained over here. Okay, so we'll go to the next animation. We can see this animation which is created by RWO Vielia, which is not created by me, so credit goes to them. So in this animation we can clearly see that the normal operation is going on, in that the OWS takes the suction from the bilge holding tank and it get transferred to the overboard. In that there is an oil monitoring device which constantly takes the sample from this line and monitor the oil content. Now the oil content is less than the 14 ppm, so that's why it has bypassed the coils adsorber. This is adsorber, it has been bypassed by it and it get constantly passed overboard. Now you can see as it been going in normal way, so the water is getting overboard in normal, and here is a display for the oil monitoring device. Here you can see that now showing green, so operation is normal. Normally it is getting transferred. Now as you can see here, now it started showing the orange, means that the oil content is 14 or more than 14, but in it is not more than 15 because it is getting overboard. If oil content is more than 15 ppm, then it bypasses to the bilge holding tank. So what I want to mention is that now by adsorber is in use because oil content is more than 14 and less than 15 or 15 ppm. So in that adsorber get in use, and we can clearly see in the oil monitoring device. So this operation is constantly running. Now this is a when adsorber is bypassed, but here you can see clearly see the screen, and by screen you can get analyzation. Now see next process what is happening. Now the oil content goes more than 15 ppm, where you can see the red indication in the oil monitoring device here, but in actual process you can see the oil content, what is the oil content in the that water. so where you can clearly see in the display, but here in the animation you can see the red means what happened, some oil is getting into the oil in the this thing in the OWS. So that oil has been monitored by this device, so it get backs to the bilge holding tank. The whatever the content it get to bilge holding and not get overboard as per the marine pollution law. Okay, now we will see what happened once this process has been going on. You can see now the water is still going to the bilge holding tank. In this animation you can see here clearly that recirculation is started. Now what happened is that once it has been sensed that there is an oil, I earlier said that there is a three electrode. So what happens is once there is an once it has been sensed that there is an oil in the system, so what it do, like the valve to the oil discharge tank start open and the freshwater valve which was been ATO, it get open, so whatever the water it get into the OWS and start to pushing that oil to the tank. You can here clearly see this water, flushing water getting into the oily water separator and it start flushing this to the oily tank or the oily bilge tank. What we on board we call it as an oily bilge tank. Now here you can see that once it sense there is a fresh water in the, now once that electrode has said that oil it is there, so that's why it has been opened, and now that electrode sense that there is no oil, now there is no water, so that's why this valve to the bilge holding tank it gets opens to flushing the system. Okay, this operation is continuous, this process is constantly going on. Now after doing this process, what will happen is this process after back flushing it, the normal operation starts, then this valve gate closes, then this water will get sucks and then the operation will takes place. Guys, you all might got an more brief idea after this animation. So this is what all about the operation and how the OWS is working, and earlier I explained the all parts and the operation of OWS. So next we will going to discuss the SOLAS regulation for the OWS. So what are the SOLAS regulation for the oily water separation? The first one is that the ship should be en route. Once we have to operate an OWS, there are some certain criteria. As in some companies we have to ask the company for operating an OWS, then they issue a permission, and we have to make a risk assessment, everything we have to follow. After that there are some regulation like ship should be en route after passing the oil water separator system. The oil content of the effluent without dilution does not exceed 15 ppm. What does it mean? That the whatever the output of OWS in that water oil content should not exceed the 15 ppm. The oily mixture does not originate from the cargo pump from bilges on the oil tanker. The third one, it says that the oily mixture, it should not originated from the cargo pump room. For that there is another system which is installed on board the tanker, so that water or the oil should not get transferred by this oily water separator. Now fourth one says that in oil tanker the oily water mixture is not mixed with the oil residue. When the ship is plying in Antarctica area, any discharge into the sea of oil or mixture from vessel shall be prohibited, as it is been earlier said that the cargo residue should not be treated by this plant. And when we are in Antarctica, when the ship is moving in Antarctica area, the whatever it is processed oil also should not be discharged. Every ship more than 400 GRT must have an oil filtering equipment. So those ship which are having more than 400 GRT, they must have this OWS system installed on board. Also the system, in that system you should have a three-way auto operated valve, which is, this is also an the requirement. So this is all about the SOLAS regulation. Hey guys, thank you for watching. If you haven't seen our earlier videos, then please do find in our playlist, and do not forget to subscribe our channel for latest informative video regarding the shipping related, marine engineering related, general videos related banking and everything. So thank you for once again, thank you guys for watching, and stay tuned for the upcoming updates. Bye, do take care.